So here we have two same identical balls. Let me try to draw. The first one coming with unknown velocity v1, its mass m. Second, same identical mass, stationary, before collision. After collision, the second ball moves in this direction. Again, its velocity unknown, but we know its direction. It's 35 degrees, as shown in this figure. The first ball will continue in this direction approximately. Velocity unknown. We should find this angle, theta. Same balls, identical. So we should find the angle of this first ball after collision. So let me draw my x and the y direction, because this is a collision in 2 dimensions. And we know that momentum conserves in both directions. And in x direction, total momentum in x direction before collision should be equal to total momentum in x direction after collision. Let me call it F final. Initially, we have only, in x direction, we have only one momentum of the first object in x direction. Second one is stationary, so that's all. After collision, two balls moving in different directions, as shown in this figure, so they have a component, x component. So the first one, mv3 times cosine theta. This is the first ball's momentum in x direction, and the plus momentum of the second object in x direction, cosine 35. So same balls, so mass we can cancel. We can remove masses. So v1 equal to v3 times cosine theta plus v2 times cosine 35. Now let me repeat the same, let me apply the same theory, same logic in y direction, in vertical direction. So total momentum in y direction before collision should be equal to total momentum of the system after collision. So before, zero momentum in vertical direction, because we have a motion in horizontal direction. After collision, the second ball is moving upward. It has its component sine 35. Second one is moving downward, so it will be negative mv3 sine theta. So from here, from these equations, from this formula, v2 sine 35 equal to v3 sine theta. So now let's check. We have two equations and how many unknowns, basically v1, v2, v3 and theta. 4 unknowns, but we have only 2 equations. So in terms of mass, we cannot solve this problem by using 2 equations. We need one more equation at least. So let me apply conservation of momentum, because this is elastic collision, so mechanical energy conserves. So total energy before collision should be equal to total energy after collision. So initially we have a kinetic energy of the first ball. Finally we have a kinetic energy of the 2 balls. So we can write this kind of equations. Then we can remove mass and 2 from this equation, and finally we'll get this kind of equation: v1 square equal to v2 square plus v3 square. So this is our third equation. Now we should think about these 2 equations, how we can solve this problem. So here I can see cosine theta and the sine theta, and from mass, from trigonometry, we know that cosine square theta plus sine square theta equal to 1. Let me try to apply it here. So from this equation, v3 cosine theta equal to v1 minus v2 cosine 35. From this equation, v3 sine theta equal to v2 sine 35. So let me take square of both sides and let me apply it for both equations and let me add to each other. Then we can cancel cosine square plus sine square. It's equal to 1. So from this equation, v3 square cosine square theta equal to v1 square minus 2v1 v2 cosine 35 plus v2 square cosine 35 square. Let's see, maybe we'll get useful information. Let me take square of the second equation, both sides. v3 square sine square theta equal to v2 square sine square 35. And let me add these two equations to each other. As you see here, v3 square cosine sine square, it will be just v3 square. And we need to add the right side. Same here, v2 square cosine square sine square, it will be just 1 or v2 square. And v1 square, this one, and minus 2 v1 v2 cosine 35. Now we need to think a little bit. And v3 square equal to, from this equation, v1 square minus v2 square. This is v3 square, which is equal to this one. v2 square plus v1 square v1 v2 cosine 35. So v1 square will be cancelled. And 2v1 v2 cosine 35 will be equal to 2v2 square. It means v1 cosine 35 equal to v2. So we have this kind of information. Because second one here, v2 should be equal to 0, which is impossible. So we ignore this answer. So second answer is v1 cosine 35 equal to v2. How we can use this information to find v3? So here we have a relationship between v2 and the v3. Here again we can get the relationship between v2 and v3 because we know the relationship between v1 and the v2. So from here v1 equal to v2 over cosine 35. Let me use it, let me substitute it here. So v2 square cosine square 35 minus v2 square equal to v3 square, or we can say v3 equal to v2 over or times tangent 35, because you know this part equal to v2 square times tangent square alpha. So again we have this kind of relationship. Let me copy it to the new page. So from here we can easily find angle theta. So let me divide these two equations. So sine theta equal to sine 35 over tangent 35, which is equal to cosine 35 basically. So sine theta equal to cosine 35, it means theta equal to 90 minus 35. So theta will be equal to 90 minus 35, 55 degrees.